All right. So here we have a formula that you have never seen before, but by the 11th grade, you should know how to work with formulas. A, B, C. There's A, there's B, there's C. And then you put it into the triangle, or into the formula. S equals the half perimeter of the triangle. So the perimeter of the triangle equals A plus B plus C. S equals A plus B plus C divided by 2, which is 15, right? So you put that in. 15. 15 minus A is 7. 15 minus B is 5. 15 minus C is 3. Yeah? Okay. So 5 times 3 is 15. 15 times 15 is 225. Times 7 is... I can't do that in my head. How embarrassing for me. $225 times 7. 200 times 7 is 1,400. 7 times 20 is 140. So 1,540. And 7 times 1,585, right? 1,575? Okay. Square root of 1,575. Now, is that okay? Well, I asked you to answer in an exact and a mixed radical. So is that okay? Is that half my answer? Half my answer. Now I got to simplify that. But that is yucky to simplify, isn't it? Because it's so big. Can I simplify right there? Sure I can. Because what is that 15? Isn't that 3 times 5? And then I've got another 5 and another 3 and a 7, don't I? And what's my index that I'm looking for? No, the index. What number should be written there that isn't? 2, which means I'm looking for groups of what? Groups of 2. Is there a group of 2? So out comes a 3. Is there a group of 2? So out comes a 5. What'd that leave under there? 7. What do I do with the 2 coefficients? 15 root 7. Yeah? Yeah. I'll let you all mark your work. Because a great many people are writing it down right now because they didn't do it. But that's okay, because I didn't come around and check. Whew. 16 times 6, 4 root 6. 121 times 2, 11 root 2. Ooh, Tricky McTrickleton. How do you do that? Well, that's 36 times 5, so out comes a 6. 6 times negative 2/3 is negative 4 root 5. That is, of course, 64 times 5. Out comes the root of 64, which is 8. 8 times 1/8 is 1, so that's root 5. Any questions about them? Make sure you correct your work if you actually did it. 245 is, what is that? 5's going to go into that. 49 times 5, so that's 7 root 5. 338 is going to be 144 doesn't go into that. But 169 does. So that's 13 root 2. 1250. That's going to be 625 times 2, so that's 25 root 2. 66 is root 66, because that's 2 times 3 times 11, so it doesn't simplify. Oh, I forgot the 4. How embarrassing. 52 root 2. Oh, and it's recorded forever on YouTube. Oh, how embarrassing. Whatever will I do? I guess I should go back and edit it out. Please. Yeah, because I have that much extra spare time to give to this. Huh? What? Huh? Edit out my mistakes? Are you crazy? Why would I do that? A better way to learn is to see how easy it is to make a mistake and don't make those same mistakes. 304. Oh, barf-tastic. 9 does not go into that. What's next? 16. 16 goes into that once. That leaves me with 14, 144. 16 goes into 144. Yes, it does. How many times? Not 10, 9. Yeah? Yeah. So 16 times 19. So out comes a 4. So that's negative 20 over 6 root 19. But of course you wouldn't leave that. You would make that 10 thirds. 10 thirds root 19. Now, I need you guys to be aware of something when you see that. I need you all to be aware that that is also negative 10 root 19 over 3. Everybody cool with that? Yeah? Because very often writing the exact same thing but having it look different is very difficult for you guys. I don't really get why. Is everybody cool with this and this being interchangeable? Okay. Word. 980 is 49 times 2 times 10, isn't it? Yeah. So that would be 7 root 20. Does that work? Yeah, but 20 is 4 times 5, so that would be 14 root 5. Whew! That was a tricky one. 272. What's that one? What's that one? 16 times 17? Cool in the gang. So that's 16 root 17. 288, that's 144 times 2, so that's negative 36 root 2. Get some highlighter action going. Yo! I marked 1 and all the multiple choice. No. It does suck. You know what else sucks? How hard it was for you to find a water fountain or whatever it is you needed to do outside. That was really complicated. I feel sorry for you that it took you that long to do that. 369, 9. 9 times 41, 6 root 41. Hey, 64. What? 2 root 91? I choose to believe Ayaka. 91's a prime number. 450 is 45 times 10, which is 9 times 5 times 5 times 2. So a 3's coming out, a 5's coming out, so 15's coming out, so 30 over 5, which is 6 root 2. And, P32, that's not a right answer. 341. Oh, that's a pickle. Is it the same? Yeah, I think it is. Because 9 doesn't go into that. 10 doesn't go into it. 11? 11 and 31? Yeah, no pairs there because those are both prime, so it stays the same. Woo! What a smart class of grade 11s I have. Stop it! Make me so happy. What am I ever going to do with myself if I don't have to teach any math? I know, right? If you can't accessorize, you might as well go naked. We're good. I guess we move along. What time is it? 21 minutes left in class. That's go-onable. Page 33. Adding and subtracting radicals. Okay. Cast your minds back. Cast your minds back. Cast your minds back. If I were to ask you to add 2x and 3x, what would you do? The answer is what? 5x. Great. What did you do? You added 2 and 3. Why were you allowed to do that? Okay, so that means by that argument, you add the numbers because they're both the same. You know their values. What values? Okay, so that would mean 2x plus 3y would be what? No, of course not. So what about this makes it right? You all can do it, but just being able to do it doesn't mean you know why it's right. Dupinder. Right. This is saying all of you should remember this. 2 x's, yes? And then 3 x's, yes? For a total of 5 x's, right? What do we actually call that in math? Collecting what? Right. This is collecting like terms. And when are we allowed to do it? When the variables are the same. When variables are the same. What do? We add what? What do we call that number? We add or subtract the coefficients, right? And I'm just going to write add because subtraction is just adding negatives. We add the coefficients. Correct? All right, so let me ask you this. Can I do this? 2x squared plus 3x. Why not? Hold up. We're going to ask Tirath. I know you weren't. Get back up here. That's why I did it. I don't believe in this newfangled thing where I let kids do what they want and then I have to deal with them not knowing how to do stuff. Why can't I do that? You guys said the variables are the same. Well, there's an x and an x. One of them is an x squared. X squared is not x, is it? So it's not enough to just be the variables, right? Everything has to be exactly the same, correct? All right. This is a coefficient. That coefficient multiplies this, doesn't it? Okay. Now tell me what this, and this thing I'm about to write in gray, What do those three blue things share in common? They all have a coefficient, right? And that coefficient multiplies the thing right beside it. Yes? Okay. So if they share all of those characteristics, then you all should already be able to tell me what that answer is. 5 root 3. Why? Because 2 root 3's and then 3 more root 3's gives me 5 root 3's. So, when can we collect like terms of radicals? We can collect, not the coefficient, we can collect like radicals when? What has to be the same? Over here it was the variable. Over here it's the... Anybody remember the word? Right. When the index... Now, index plural is a word that you people aren't going to like. It's indices. I-N-D-I-C-E-S. Indices is just when there's more than one index. So I'm going to use the real word because why not, right? When the indices and the... Anybody remember what the name of that thing is? And the radicands are the same. And that is just like the math that you already know how to do, because the variable and the exponent must be the same. And in radicals, the index, because the index is the exponent, isn't it? And the radicands must be the same. Is everybody good? Great. So, in that first one, what do I need to do? Do I see any like terms? Nobody sees any radicands and indices that are the same? 1a. I see root 7, root 7, root 7. Are they all the same radicand? Are they all the same index? So what do I do with the coefficients? Add them up. What is it? Negative 2 root 7 plus root 2. And I'm done. Why am I done? Because can't do anything with that. Now, looking at B, can I do something with it now? No, not right now, because they're different radicands. Can I make them the same? By doing what? So, simplify. When? When should I simplify in math class? When should you simplify in a math class? Only then? Whenever possible. Simplify at the beginning of the question. Simplify halfway through the question. Simplify at the end of the question. Simplify a third of the way through the question. Simplify, 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 simplify. What is that really? 16 times 2, right? What's that really? 4 times 2. What's the square root of 16? 4 root 2. Plus, what's the square root of 4? 2 root 2. Now, can I put them together? And what do I get? 6 root 2. Everybody good? Sweet. You guys do C and D. Go. While I decide how much work I give you. Oh, that's hurtful. I'm going to go over these two, and your homework tonight is going to be page 34 to 35. You will have 10 minutes in class, plus... How do I fix up 28? 4, 7. How do I fix up 63? 9, 7. How do I fix up 112? 16, 7. Square root of 4? 2. What happens to the 5? 10 root 7. Minus. What comes out? What happens to the 3? 9 root 7. Plus. What comes out? What happens to the 2? 8 root 7. Are they all root 7 now? So what is it? 9 root 7. Yay! What about this guy? What's that? 4, 5. What's that? 9, 5. Out comes the 4. 2 root 5. Minus 9 root 5. What do I get? Negative 7 root 5. Everybody should be good, yeah? I believe that every single one of you should have done adding of radicals in grade 10. I know that I taught it to my classes. You do 34 and 35. Be very wary of D. Because what do you got to remember how to do when you start adding up D? What are you going to have? Barf. Denominators. Yuck. 34 and 35's homework. I will be marking your test.